Hello friends, this is your crew from the White County Library, and since you can't come see us, we thought we would come see you today with a fabulous video showing some science experiments that you can do around the house. We've gathered a lot of household items that you're going to have at home so you can replicate the things that we're doing here today. So we're going to get started and show you some science experiments.
Right now, we're going to make some oobleck. Oobleck is really simple to make. You just need a box of cornstarch, ask your grown-up before you go get that out of the cupboard, and a little bit of water. Oobleck kind of looks all watery, like a big old bowl of milk, but it's so much more than that. Oobleck is what's called a non-Newtonian fluid. Non-Newtonian just means that it doesn't obey one of those fancy science laws by Sir Isaac Newton, called Newton's law of viscosity. You see, even though it looks like it's a liquid, you can pick it up like a solid, but then it melts. The law of viscosity states that temperature is going to have an effect on how gooey something is. But oobleck doesn't care about your silly laws. Oobleck is going to be hard when you squeeze it, and it's going to be melty when it's at rest. It's really fun to play with. You should try to make some and see what you can sink to the bottom of your oobleck. And then see if you can get it back out. It's very difficult. Have fun.
For our next trick, we're going to be looking at the science of polymers. And for that, we're going to be using this little Ziploc bag you can get at your house, and it's just filled with water. And this is going to be something really fun you can try on your brothers and sisters. But right now, I'm going to try it on Miss Dana. So, Miss Dana, if you come over here and stand underneath the bag, I have some sharpened pencils. And I'm going to slide this sharpened pencil through this bag, and we're going to see if any water comes out on Miss Dana's head. Are you ready, Miss Dana?
Uh-huh.
Okay. Oh my goodness. Are you dry?
I am.
Can I do it again?
Okay.
Okay. So the reason that Miss Dana is still dry is because the plastic that this bag is made out of is made of polymers. And when we push the pencil through, the polymers surround the pencil and cause a seal. And that is why Miss Dana is not wet. Pretty cool.
For our next experiment, we're going to do something popularized on night TV that's on way late at night that your parents did not let you watch, called Will It Float? What I have here is a Rubbermaid tote. Actually, I think it's a Sterilite. Sorry, wrong brand name. And it is about 3/4 of the way full of water. We've used a clear one where you can see it on camera, but you can use any color when you're at home because you'll be able to see down inside. And we have various items that we've collected here in front of us. Julie, won't you hand me the rock first? Okay. Will a rock float? What do you think? Yes? No? Let's see. Oh, it sunk pretty fast. Did you hear that? Oh, and it's blowing bubbles. I don't know if you can see that at home, but it's like letting bubbles out. Some rocks will float. Look in your mom's bathtub, and I bet you might find a rock that floats. All right, let's see what's next. Let's have some fruits and vegetables. What do we have? Can you reach anything, Mom?
How about an orange?
How about an orange? Is there an apple too? There is an apple. Okay, all right, so let's take an orange and an apple. Do you think either of these will float? What do you think? How many think orange? How many think apple? How many think neither? Or maybe they'll both float. Let's see, here we go. Ah, they both float. Okay, all right. What other fruits do we have up there? A lime and a lemon. Okay, now the orange and the apple are both floating. The rock has sunk, and now we have a lime and a lemon, both about the same size. What do we think is going to happen here? Float, sink, sink, float. Here we go. They both float. Huh, interesting, isn't it? Very interesting. All right, what else do we have up there? We have a green bell pepper and a red Roma tomato. Let's see what happens. They both float. Wow. I would have thought the bell pepper would have floated, but I would have thought the tomato might have sunk. Okay, now we have sodas. We have a can of Sprite. Let me move my items a little to the side here, okay? And a can of caffeine-free Fanta berry flavored soda with other natural flavors. Here we go. What do you think? Sink, float? Sink, float? If you see that, we had to wait for just a minute, but the Sprite floats and the Fanta sinks. Whether something floats or sinks depends on the density of the item, how much it weighs, the mass. There's a lot of things that go into whether it sinks or floats. So even though you have items that are similar in size and shape, even in structure, sometimes one will sink and one will float. So there's a lot of things that you can grab at your house and try to see, but make sure mom and dad say it's okay, because you don't want to try to sink or float the cell phone. Okay, that is a very bad idea. Bad idea. But there's a lot of things around your house that you can try and see if it would sink or float. And I hope you have a lot of fun with this one and you get nice and wet. And have a great day trying out science.
Have you ever been on a merry-go-round and feel like you're being pulled directly out of your seat? That force that's trying to pull you away from the center is centripetal force. I've got an experiment that'll show you how centripetal force works with water. Now, this is real water for those of you at home. And I'm going to attempt to throw this whole bucket in a circle without spilling even a drop of water. Ready?
No.
This might be an experiment for you to do outside, but I know this works. I am so sure it works. I'm gonna do it in the library with all the books.
No, not the books.
Calm down, it works. All right, are we ready? Here we go. You guys got a countdown for me? 3, 2, 1. Nothing spilled. Centrifugal force holds the water to the bucket when it goes in a circular motion. Have fun with this one, but you may want to take it outside. Our next experiment is launching rockets. We have film canister rockets that we've made with paper and just little plastic film canisters. The bottom of it will come off really easily. We also have antacid tablets. We're going to put the antacid tablets in the film canister with a little bit of water and quickly put the lid on and watch them launch. The science behind this is that carbon dioxide will build in the canister so much carbon dioxide that the lid will pop off, sending the rocket flying.
You don't need a whole lot of water, but you do have to put it in quick. Quick squirt, lid on.
And when you have your water in there and you put your antacid in there, you can play around with how much you put in. The more antacid you put into your film canister, the larger the chemical reaction will be, and you can see how high your rocket goes.
And since we can't show you what's happening inside of our rocket, we're going to show you right here in a clear measuring cup and one of the antacid tablets from the packet. I'm just going to drop it in, and immediately you see the fizzing start. Now that one I dropped in whole. This one I'm going to break it up into little pieces where you can see the difference. And you can decide how you want your rocket to go based on the reaction that we get. Okay, this one's broken into smaller pieces. I'm still trying to break it up just a little more. And I'm going to just pour it in there. That one right there is still going. It's kind of like a slow fizz. But when you break it up into smaller pieces, you get a lot of action quickly. So if you break yours into smaller pieces, you're going to have to get that lid on there quickly and get it down for it to explode like you want it to. Now for the rest of this experiment, we're going to take it outside because you do not want to set these off inside your home, okay? Make sure you do the rest of this experiment outside. So we're going to stop the video and then we'll meet you outside. We all colored and designed our rockets differently. Mine has got polka dots and it kind of looks like a candle when it's sitting up. What does yours look like?
Mine looks like a birthday cake or something. I don't know. Confetti. Yeah.
Mine's got a wonky top. We'll see how that goes.
Mine's a little bit shorter than Cathy and Michael's, and it has a heart that sticks out. It might affect its aerodynamic properties.
Cool. All right, well, we've broken up our antacid tablets. They're inside our film canisters. Film canisters look just like this. If you don't have them, you can get them on Amazon. They have a snapping tight lid. It's important that this lid fits tight to control the chemical reaction that's happening in here. But when this explodes, the cap will come off. So you're going to have to be watching to see where your cap flies, okay? Our antacid's in. We have squirt bottles to help put our water in it. Mine says hot. It's really not. I don't know why it says that, okay? So Dana and I are going to go first, and then we're going to hand the bottles off to Julie and Michael. So are you ready?
Yeah.
All right, here we go.
Oh, no. Oh, I couldn't get it on.
Mine's on. Oh no, mine's coming out the bottom. It's not working. I think mine and Dana's are leaking out the bottom, so I don't think we got our caps on tight enough.
Well,
Let's try it again. It's trying though.
But knock it over first.
That's right.
Get rid of the
It's I don't know, mine's still wiggling. Let's see if we can give it.
We're going to try mine again.
Are you? Okay. All right, so sometimes it works and sometimes it doesn't. But either way we have That's why I'm not picking
explodes
mine
in your
up.
face.
Either way we have fun, and it's a lot of fun learning how science works. If you're looking for science books, we have plenty of them at the library. Give us a call. They have experiments just like these that you can do at home and learn more while you're there. Stay safe, social distance. Sorry, we weren't doing a good job. Social distance, and learn while you're at home. Thanks for watching.